Hello everyone. So in the previous video I have given you the overview of linear regression and gradient descent. So in this video we will start to code our project. So before coding, we'll start by importing the pandas library to import our CSV dataset. After importing, we get this Unicode escape error. It is nothing when your dataset path contains backslashes. The Python treats it as a escape sequences, which is a new line like backslash n or backslash t. So in order to overcome this, we will write r at the starting of our dataset path. So after running the cell again, we get our dataset. So here are the columns and their values. So for this project, I'm going to use the auto mpg dataset, which is nothing but the specification of car is given, like the cylinders, displacement, horsepower, weight, acceleration, model year and origin, and the car name. And based on that, its miles per gallon, that is its mileage is given in miles per gallon. Now from the entire data set, we don't require all the columns, we only require important columns. So we will drop the columns like model year, the origin and the car name, which is not useful for our project, and we'll keep the remaining columns in another data frame. Now from the another data frame, we will divide the another data frame into two parts, that is x and y. X will be our input columns, that is the independent variable, and y will be our output column, that is the miles per gallon column, which we want as the output for the input features of x. Hence x will contain columns from cylinder to model year, and y will contain miles per gallon column. Now as you can see that our data set has a very different range of values. Some columns contain a single digit value while other contains even 3-digit values. So hence we need to standardize our data set. For that we are going to use the standardization method from the sklearn library, that is standard scalar. So when I use the standard scalar class from the sklearn library, I got an error that the horsepower column contained a question mark character which cannot be standardized. So hence we need to first handle that error. So I checked the horsepower column and converted the question mark into null, and then deleted the whole row from the data frame, and then again passed the data frame to the standard scalar. Now our data frame has been standardized. So as you can see that our data set now has standardized values, and here is the hist plot. Hist plot gives us the frequency of the elements in our data sets. As you can see, our data set contains values ranging from -2 to +2, with -1 values being the largest. Now we will use train test split to split our data set into training and testing. So when I did the training and testing, I realized that I've done the split after the standardization, which can cause data leakage issues, which means that during standardization it uses the values from the entire column to calculate the mean and the standard deviation, and then convert those values to standardized values. So if we are doing standardization before the train test split, it will consider the whole column for standardization, and we don't want that. So we will do trend test split first and then standardization next. So after standardizing our data set, we will move on to the gradient descent algorithm. Now to understand gradient descent algorithm, you can refer to YouTube tutorials that explains how we derive multi-dimensional gradient descent algorithm, especially the tutorials from Campus X, which I am learning from currently. Now we are going to insert 1 at the start of each column in the xtrain and the xtest gradient descent, which is b is equal to b minus the slope, where the slope equation is x transpose into x into b minus x transpose into y. This is the core equation of gradient descent. But now there are three types of gradient descent. First is the batch gradient descent, mini batch gradient descent, and stochastic gradient descent. The difference is that the batch size we are using for training, in batch gradient descent we are using the whole data set, like the xtrain. In mini batch we are dividing the xtrain into small batches, and in stochastic gradient descent we are using each row as a batch itself. That means if our xtrain has 20 rows, then we are going to make 20 batches. But now I'm using mini batch gradient descent, for example, and then I will be converting that to batch GD and stochastic GD. Now after handling the errors while making the mini batch gradient descent, I am making a function batch GD, so it will be easier to call out the function and just pass the required values. Now after making the batch gradient descent function, I'm still getting some errors. Now after handling all the errors, I have fine-tuned the mini batch gradient descents parameters, like its learning rate, epochs, and the batch size. So by fine-tuning this, I will now evaluate the results. I am using R2 score for evaluation. So after running the cell, I get the R2 score of minus 8.5, which is very low. Actually, it shouldn't even be there. That means the accuracy of our model is in negative. Now, after making changes in the functions even more, I print out the values of the b and its parameters, like the value 1 and value 2 for mini batch gradient descent, and from that I figure out that my intercept and the coefficient values are very different and are quite big. So I import another model called SGD regressor, which is a ready-made model for gradient descent. SGD stands for stochastic gradient descent regressor. So I will be also using the stochastic method now for comparing my values to their class values and see where I am lacking. So I import the HGD regressor class from the sklearn library and then pass my data set of xtrain and ytrain to the HGD regressor, and I get an accuracy of 65%, which is quite good. So for some time I was just tinkering around the functions, around the mini batch gradient descent function, to see what result I get. So after changing the gradient descent algorithm and making changes in it for a long time, I got a full accuracy of 56%, for learning rate of 0.0235 in stochastic gradient descent. Now after improving the gradient descent function, I will be inputting example values of a car, like its horsepower, its weight, etc. from the internet, and just see what value it returns and compare it to the real world value. Apparently, the difference in the predicted value and the real world value is quite significant. That means our model is not as much accurate. So we need to see something about it. So after a while of tinkering, I got not that much good accuracy, but yes, it is a 56. It is a 65% accuracy on the model. Now I will be making a function on visualization. Now long time has passed, but I am still not able to get the visualization function right, and the visualization is not as I expected it to be. Hence, I'm dropping this function and just using the gradient descent function. Also, I will be making the gradient descent function into a class where we can get input from the user to which gradient descent to use, like batch GD, mini batch GD, or the stochastic GD, and based on that, it will have pre fine-tuned hyper parameter models like learning rate. The user will just enter which GD to use and will enter the train and test data, and it will give the output. So that was it for the project. It was a simple project, but I encountered very much errors in this project. So hopefully in the next video where I'm making project, I encounter as few errors as this one. So that's it. We have implemented the gradient descent from scratch for linear regression. Although we have not used everything from scratch, we are still using library of scikit-learn, like its standardization and train test splitting. But I have implemented gradient descent from scratch. And the resources that I've learned from is the Campus X tutorials of machine learning. So that's it.